Let's look at some formula solving. This is where we solve for a specific variable. In this problem, we want to solve for the a. That means that we want to isolate the a. We want to get the a all by itself. To do that, we go on the side with the a, and we get rid of any other term that's on that side. So here is our a. The other piece that's on that side of the equal sign is the b. So we would like to make the b cancel. The b is added to the a term, so to take it off, we should subtract it from both sides. This is what we had. We're going to take it away. Do the same on the other side. Clean up. That leaves only your a on the left. C minus b, there's nothing you can do there, but you have met your goal. You have isolated the a. The regular equation that this is similar to is one that is only a one-step solve, like x plus 5 equals 7. Rather than just looking and saying, okay, x is 2, if we go through the process, we go on the side with the x and we take off anything added or subtracted. So 5 is added, we should take it away. Do the same to both sides. Clean up. X is isolated. That's our goal. Exact same step here. We wanted the a, go on that side. Take off anything added or subtracted, so we want to take off the b. It's added, so we must take it away. From both sides, clean up, the b cancels, leaves only the a. The other side we can't do anything because they're not like terms, but we have met our goal, which was to isolate the a. Just a quick note here, if you're used to solving equations and you normally work vertically, like if you wanted to take the b off and you subtract, if you try to write it under, you get in a bit of trouble with formulas because when you go to the other side, you don't have like terms. So I would recommend the horizontal notation. If you're going to work vertically, don't put it under the c. You're going to need to put it over because they're not like terms. So I would recommend the horizontal notation for formula solving. Let's look at another problem. This one is solve for a, and we have a minus b equals c. So first we would go on the side of the one that we want. So we're going to go on the side with the a. We look around and anything else that's there we want to get rid of. So we want to get rid of the b. We want to notice that the b is subtracted from the a. So to make that cancel, we should add. Just like equations, so this is what we had. We'll add a b. On the left, it cancels. Leaves us just a. And c plus b, there's nothing you can do because they're not like terms. You have isolated the a. That was your goal. Let's look at this problem. Solve for p. We have p times b equals a. So first of all, go on the side of the one that you want. So go on the side with the p. Whatever else is there needs to come off. So we want to take off the b. What is the relationship between the p and the b? They're multiplied. So to reverse a multiplication, we should do a division. And we're going to divide out the part that we don't want. So we're going to divide by the b because we want to get rid of it. Do the same on both sides. On the left it cancels to leave us just p. And on the right you get a fraction, but that's okay. Your p is isolated. That was our goal. This is still a one-step solve problem. It works very much like this regular linear equation. 3x equals 12. To isolate the x, you go on that side. You get rid of whatever else is with the x. So you get rid of the 3. The 3 is multiplied by x, so to get rid of it, you divide. You're dividing out the part you don't want. And that leaves you x equals 4, so your x is isolated. Exactly the same here, except you're isolating the p. Let's look at this problem. Solve for m. So m is what we want to isolate. We should go on that side. So we have F equals m times a. Force equals mass times acceleration. But we don't really care about that here. What we care about is getting the m all by itself. So we need to work on the side with the m. We want to keep the m, so we want to get rid of whatever else is on that side. We want to get rid of the a. What's the operation between the m and the a? They're side by side, so they're multiplied. To reverse a multiplication, you need to divide. We're going to divide by the piece we want to get rid of. So we're going to divide on both sides by the a. Now, there's nothing we can do on the left-hand side, but the m is now isolated. That was our goal. Before we solve our next formula, I want to go back to a linear equation. 3x plus 5 equals 11. This is a nice standard two-step equation. We would want to solve for x. So we would go on the side with the x, and we would take off anything added or subtracted. So we would take off the 5. So we have 3x. That's what we had, and we would subtract our 5 from both sides. Clean up. We would have 3x equals 6. Now go back on the side with your variable, and you divide out your coefficient. Get x equals 2. Formulas work the same way. It's the exact same steps, except you're told which one to isolate. So on this particular formula, we're going to isolate the x. So we're going to go on the side with the x. We want the x. Look around the x. Notice the x is multiplied by the 5, so we'll leave that till last. The other piece on there that we want to take off is the f. So we will take the f off first. Anything added or subtracted should come off first. So if it's added, we're going to subtract it from both sides. Clean up. Nothing you can do on the right-hand side. Those are not like terms. Just bring them down. Now go back on the side of the one you want. You want the x, so you should be on that side. The piece that's left with it is the 5. It's multiplied, so to get that off, you're going to divide. You can divide on both sides by the 5. On this side, just do it under the whole piece. Clean up. Your 5 cancels. Nothing you can do on the right-hand side, just leave it. And x is isolated. That was your goal. Next we have a two-step solve problem. We want to solve for t. So we're going to go on the side with the t, find the t. That's what we want to keep. So we look around the t. Notice the t is right beside the g, so they are multiplied. We'll leave that till last. Take off anything first that's added or subtracted to your t term. So the k should come off first. Now we want to make the k cancel. That's a positive k, so we're going to need to subtract it from both sides. You should write it at the end. Don't write it in front of the v. You'll mess up the sign. So we're going to subtract a k from both sides. We'll cancel on the right. Nothing we can do here. They're not like terms. Now go back on the side of the one you want. We want the t, so we're looking on that side. Whatever else is there is what we want to get rid of. So we want to get rid of the g. The g is multiplied, so to take it off, we will divide. So we're going to divide on both sides by the g. Now, there's nothing you can do on the left because these are not like terms, so we'll just leave that. It's okay that it's a fraction. On the right-hand side, the g's cancel. T is isolated. That was our goal. Let's look at one more problem to solve for a variable. We will solve for the r. And so we'll always go on the side and find our variable that we want. So here's our r. The one right beside it, the I squared, is multiplied by the r. Other things on that side, we have a 10 that's added. You always take off first anything added or subtracted to the term you want. So we're going to get rid of this 10. It's added, so we're going to subtract it from both sides. Clean up. There's nothing you can do on the left. These are not like terms. Your 10 cancels on the right. That was our plan. Right, now go back on the side of the one you want. So you want the r, you need to be on that side. The only thing left we have to get rid of is the I squared. Notice it's multiplied by the r. So to get it off, we will divide. We're going to divide on both sides by I squared. We'll cancel on the right. On the left, you're just going to leave it. There's nothing you can simplify there. So you have p minus 10 over I squared equals r.